All right, everybody, welcome to the video for lesson number 2 on rational exponents. Hopefully I don't make any mistakes in this video. I know there was one in video number 1, so if you found it, good for you. So for number 1, I noticed that it says that c has to be greater than 0. It's probably going to say that because we don't want to have negative numbers in our radicals here. Also tells us that a is a positive integer, right? If that was a negative integer, that would change things. It would make it not as easy of a question. And it gives us this fractional exponent. So if I have a fractional exponent, I know what I'm using here is the rule of exponent over root. So as soon as I see this, I'm thinking exponent over root. So if I was to rewrite this as a radical, whatever is raised to that fractional exponent is in the radical. Since the root is a, I'm going to put a in the little index spot. And since the exponent's 4, I'm going to raise that to the 4th power. This is a perfectly acceptable answer. An equivalent answer would be 16c to the 4th, because 2 to the 4th is 16. Number 2 is similar but different. It's still going to be exponent over root. But notice it's a negative number. The negative number tells us this is a fraction, because remember, negative exponents are repeated division. So I'm going to start by making a division sign with a 1 on top. I know the index is a, so I have an a root of negative 2c to the 3rd power. If I wanted to simplify that further, I can say 1 over the 8th root of negative 8c to the 3rd power. That would be the best possible answer. Now, think for a little bit here, because I could actually expand on this a little bit. If that number is negative, that means either c cubed has to come out to be a negative number, or the index has to be odd, because remember, odd indexes from unit 3 are allowed to have negative radicands. All right, so let's move on here then to number 3. So for number 3, I have this expression, and it says, explain why this can be expressed as the cube root of 16. So the first thing I would do here would be to change 4 squared to 16. So I know that 4 squared is equal to 16. So I can say this is 16 to the 1/3 power. Then I know that's equivalent to the 3rd root of 16 because of the rule of exponent over root. So I can say these expressions are equivalent because fraction exponents are in the form exponent over root. Notice this word tells us I have to put this there. Just showing the math is not enough. For number 4, it gives us a radical and it asks us which of the following is equivalent. So because it's a radical, we now have to use this exponent over root rule backwards. So I can make the cube root of 27, that's just 3. A to the 6, negative 6 power, well, that's going to be divided by 3 because of the exponent and the root. B is going to be 3 over 3, and C is going to be 2 over 3. Now, if I simplify, I get 3a to the negative 2 b, and c to the 2/3. I don't want a negative exponent because I notice none of my choices have a negative exponent. So I'm going to rewrite that so that the a squared is in the denominator, meaning it's not choice 3 and it's not choice 2. And in the numerator, I'm left with a 3, a b, and I have a cube root of c squared, because this should be the cube root of c squared. Meaning I have choice 4. Nope, not choice 4. Choice 4 doesn't make sense. We have choice 1. The reason why choice 4 doesn't make sense is I have this extra 3 in here, which we don't want. That's not good. All right, so moving on. Number 5 says, what is the value for x? So if I divide both sides by 2, I get x to the 1/2 power equals 16. Well, x to the 1/2 power is really the square root of x equals 16. So then if we square both sides, I get x equals 256. The next one looks way more difficult than it actually is. So the first thing I would do here would be combine all of these together. So I know when I multiply variables, I add their exponents. A fourth plus a half plus a fourth is 1. So I have a to the first power squared equals 9, or a squared equals 9. If I square root both sides, I get a equals plus or minus 3. So there's 2 answers for this question. Number 7 wants us to write everything in this form. So when I rewrite these questions, I'm looking for a constant value to be the coefficient and a exponent, whether it's a fractional exponent or not. So if I look at a, I know the 4th root of 16 is 2. And I know x to the 3rd underneath the 4th root is really x to the 3/4 because of exponent over root. That's in this form, so I'm done. K winds up being 2, n winds up being 3/4. If we look at b, the first thing I would do here for b would be simplify that 9. So I'd have this as 27 I don't know what just happened there. So I'd have this as 27 over 3x to the second. Where did I get 3x to the second from? Well, I know the square root of 9 is 3, and the square root of x to the 4th power, either I know the square root rule, or if I change it to exponent over root, since it's a square root, there's really a 2 there, this becomes x squared. So then I could do some division. 27 divided by 3 is 9. And I'm still not in the form I want. Remember, I want to be in kx to the nth power. I'm not in that form yet. So I can use my exponent rules to make that x to the -2, essentially bring this up. Now I'm in the form that I want, where k is 9 and n is -2. Oh, that's it. So hopefully this helped doing your homework. I know the fractional exponent stuff seems challenging. It's really not. If you understand the basic rule of exponent over root, it's pretty easy. Tomorrow in class, maybe we'll do some practice with it before we move on to graphing. All right. Best of luck, and expect a quick quiz at some point.